Well, in this video, we're going to be continuing our discussion on Chapter 3, and we're going to be talking about significant figures. Here's the goals for our understanding of significant figures is to state the number of significant figures in a given quantity that would be expected if the section title is called significant figures. We want to also, though, be able to round numbers to a specified amount of significant figures, add or subtract given quantities and express the result in the proper number of significant figures, and then multiply or divide given measurements and express the result in the proper number of significant figures. And we'll be doing these all in separate videos. So what are significant figures and uncertainty in measurement? Well, no measurement is exact. So in scientific writing, the uncertainty associated with a measurement should be always included or is always included if they're good scientists. So by convention, a measured quantity is expressed by stating all the digits known accurately plus one uncertainty digit. So let's do an example here together. So let's say I wanted to measure this board here, and I wanted to do so using this ruler. Okay, so this ruler, I'll tell you, is 1 meter long. And in the first example here, there's no marks on the ruler, right? So I'm pretty uncertain about this measurement. And if I estimate that that's about half the length of this meter stick, it appears that the board on the top of the meter stick is longer than that. So, maybe 0.6 meters, let's say. But it definitely seems like, it's less than 0.7 meters in my opinion, okay? But the point is I'm uncertain. So we denote that uncertainty here using this plus or minus symbol, okay? And we're gonna say this is 0.6 plus or minus 0.1 meters. In other words, there we go. It might be 0.1 meters less, it might be 0.1 meters more. We're uncertain about that. And this is our uncertainty digit, okay? So moving on now, let's get a little bit more precise. So we go in our cabinet, we grab another meter stick. This one has markings that are every 10 centimeters apart or every 0.1 meters apart down here, okay? And then we want to measure the same board. Well, now if I look at this, this is definitely over 0.6 meters or 60 centimeters here, okay? But if I want to guess the next digit here, I'm going to guess that maybe it is 0.64, okay? Because it doesn't look like it's quite between the 0.6 and 0.7 mark or the 60 and 70 centimeter mark. So I'm going to guess it's 0.64. Again, I'm uncertain about that last digit, so I write that uncertainty here, okay? So this is my uncertainty digit. I'm not too sure about that measurement. I know for sure the 0.6 now, but not so sure the digit after that. Okay, so now let's add marks. We grab another meter stick. Meter sticks abound in this lab that we're in. We grab another one, and this one has marks every centimeter apart, So this is like 61, 62, 63, 64, 65, etc. Or 0.61, 0.62. Okay, so now here, I'm very confident in this part, but the next part in between there in the millimeter category, that's a little uncertain. So I'm gonna say maybe this is 0.642, just me guessing, plus or minus, I'm gonna write my uncertainty in this way, okay? Where again, this is my uncertainty digit. And this is really similar to a lab you're going to be doing this week. So this is just to introduce you to the things that you'll be doing in that lab. And hopefully it helps. So if we go on now we have a meter stick. We grab a final one out of the cabinet that has markings for every millimeter. And if you could see on your screen, it's hard for me to see, but this actually reads 0.643. But really beyond that, I can't tell. I can't really make even an estimate in between those millimeter markings, especially not on this screen. So I think we've reached the limit of the instrument that we're using, the instrument being this meter stick. And, you know, slight differences in how we align the board to the ruler and how we do all these things are going to affect the uncertainty. Okay, so we've reached the limit of our measuring device. So this is how we're going to express our quantity. All right. So this is, again, just an intro to uncertainty and measurements. And if we go on, here's kind of a big overview of significant figures. And on the top here is something very important. It says significant figures are applied to measurements and quantities calculated from those measurements. So they don't apply to exact numbers, okay? They don't apply to things like counting numbers, okay? Or things that are fixed by definition, like the number of hours in a days. Such numbers have no uncertainty, okay? So that's something to remember. Significant figures, exact numbers don't have uncertainty, like counting numbers or numbers fixed by definition. Okay, so moving on then, the number of significant figures in a quantity is the number of digits that are known accurately plus one uncertainty digit. We talked about that. The measurement process, not the unit in which the result is expressed, determines the number of significant figures in a quantity. All right, so the instrument we used in the last example, the meter stick, determines the uncertainty. The location of the decimal point, this is something important, has nothing to do with significant figures. So the same 0.643 meter board can also be expressed as 0.000643 kilometers long. The 3 zeros here are not, oh, I included a 6 in there. No, hold on. Oh, excuse me. These guys are not significant, okay? So keep that in mind. And we're going to do examples to clear any confusion up that you may have if this is unclear right now. This is just kind of an exhaustive list of everything. You begin counting significant figures at the first non-zero digit, not at the decimal point, okay? The uncertainty digit is the last digit written, okay? And if the uncertainty digit is a 0 to the right of the decimal point, the 0 must also be written. And you might see this when you weigh something on a scale. It might weigh 0.10 grams, let's say. That 0 must be included when you're doing a lab. And then exponential notation, must be used for very large numbers to show if the final zeros are significant. Okay, so let's do an example. Here's some rules on the left, and we're going to do the example on the right. All right, so the rules are all non-zero digits are significant. Zeros between two significant figures are themselves significant. Zeros at the beginning of a number are never significant. And zeros at the end of a number are significant if a decimal point is written in the number. Okay, so let's go on to this example on the right. How many significant figures are in each of the following quantities? Well, from our first rule, if we look at this number, all non-zero digits are significant. So there are 1, 2, 3, 4 non-zero digits. They're all significant. This has 4 significant figures, okay? Let's look at the next example here. Well, remember from before that we start counting at the first non-zero digit. So we skip over this 0 and we start counting here. And we count, so 1, that 0 is going to be significant because it's between two significant figures that are themselves significant. And this 9 here, all right, is also significant. So this number has 3 significant figures. How about this next example? Well, again, we're going to begin counting at the first non-zero digit, and all non-zero digits are significant, so this says 2 significant figures. Okay, so I hope you're getting the hang of this. Finally, in this example here, this has 1, 2, 3, 4, 5 significant figures. And you may be saying, well, whoa, why aren't you counting the exponent? Well, remember, exponents are just a way for us to express really small or really large numbers. And if you put this in ordinary decimal form, you'd have a lot of zeros in front of this number, in front of the 2, that aren't significant. But an easier way to remember that is that you never, okay, so don't count exponents as significant, okay? That's the easiest way to remember it. If you see an exponent, ignore them. They are not significant. All right. One final thing I want to say before I end this short video is that what about this last point? Zeros at the end of a number are significant if a decimal point is written in the number. What do I mean by that? Well, let's take this example. Okay, that's a decimal point there and the one in the bottom. Okay, how many significant figures does each of these numbers have? Well, if we go by this rule, the top number only has 1 sig fig. The bottom number has 3 sig figs. Why? Because that decimal point is included in the bottom number. So I count the zeros at the end of the number, but there's no decimal point in the top number. All right, so those are not counted. Okay, so I know that might seem a little confusing, but I hope it's not. I just want you to recognize that and be on the lookout for those decimal points. There shouldn't be so many examples of that this semester, but just be aware, okay, that if zeros at the end of a number are significant if a decimal point is written in the number, okay? So I just wanted to give that final example. We'll stop there and we'll go on to rounding significant figures in the next video.